Now let us start with the session on SAP HANA Operations topic. In this topic, we will learn about how to stop, start, restart SAP HANA database and how to monitor the status of SAP HANA database and how to configure HANA database, what config files are relevant, which are very important for making configuration settings, what are table definitions, how to check the table content, what do we mean by table partitioning, how it is done, what are the advantages of table partitioning, and basic idea about choosing row based and column based storage for tables and transport of content. Let us first start with starting and stopping SAP HANA. Why do we have to start and stop SAP HANA? Whenever we make any configuration changes or whenever we have software updates or hardware updates scheduled, during those operations it is necessary for us to start, stop SAP HANA, then again check the status and then do the operation like hardware update or software update, then start the SAP HANA to bring it online. So basically, for any maintenance activities, for any life cycle activities, we make this stop of SAP HANA, then we execute the maintenance activity, then start the SAP HANA. And with respect to updating HANA software, the update program itself will stop, update the software, and then start the SAP HANA database. Whereas with respect to configuration settings, we have to manually stop and then start the SAP HANA. So how do we do this? There are multiple ways in executing stop start of SAP HANA. Using OS commands is one option, and second option would be to use HANA Studio. So coming to using OS commands, we can use to start use HTTP start command, to stop HTTP stop command. With respect to OS commands, again there are two options. That is, one, we can use the HTTP program, other we can use the SAP control program. So we studied how we start and stop with HTTP program. For this, we have to log in with SID ADM credentials. Only SID ADM is authorized for stopping, starting the database. So once we log into root shell, we have to switch to SID ADM user, then issue HTTP stop and then HTTP start. Coming to SAP control executable is a part of the kernel. So we have to first issue the stop command once the configuration settings are done. So use the SAP control with -nr, give the instance number, then function, then give stop. Similarly for start, use SAP control with -nr, give the instance number, then -function, start. And once the stop start is executed, we will have to check the status of SAP HANA database. So that is again done using SAP control program or HTTP program. When we want to use the SAP control program, it is with option get process list. So in a similar fashion, like how we start and stop, we have to use SAP control -nr, give the instance number, then -function, issue get process list. And when it comes to HTTP program, it is HTTP info. Again for this, we have to log in with SID ADM credentials. Only then we can check the status of HANA database. See, now I have logged into the HANA database server and I have switched to SID ADM user. So once I switch to SID ADM user, I will be navigated to instance directory, that is HTTP01, under which I will have the HTTP program stored. So from there, if I want to stop, I just issue HTTP stop. And once we issue, you can see that internally HTTP program also uses SAP control program with option protocol ni underscore HTTP and then -nr01 is the instance number, then function stop, and this is the wait time for the stop in seconds. So once I issue this, it will work on it and then it stops and issues the successful status as OK. And here you can see HTTP daemon is now stopped. And if you check the processes running with HAN ADM, where HAN is the SID, you see that only SAP start SRV program is running, which has to be manually stopped. So for that I issue kill command with -9 and the PID of this process. So once this is done, I can proceed to start it again. So I issue HTTP start again from the same location. So this again from SAP control, it stops. So internally it calls SAP control with the same set of options, and this is the wait time in seconds, and it proceeds to start. So this process will run for 2700 seconds and then only it comes out. So after that I can verify the status of HAN ADM processes, that is, which will show the status of HAN database. So once the start is completed, we will get the successful message there, and after that we can proceed to check the status of HANADB. That is, by using HTTP info we can verify whether HANADB started or not. So I will just issue HTTP info, and from there I will get the list of processes running with HAN ADM user, and here you can see all the HANADB process components running, all the servers running. So that means HANADB is up and running. So in a similar fashion, I can issue SAP control program with function get process list, and this will show a detailed message, a detailed picture of each process, whether they are running or not. See, everything should be green here. See, some processes are still yellow. That means the database is not started completely. I will have to recheck why these processes are still in yellow status. Ideally, for HANADB to be completely up and running, all these processes should be with green status. And here you can see different information like start time, elapsed time, and the PID of each process. So ultimately, HTTP daemon being the parent of all the processes should be in green color. That will be in green if all other processes, all other dependent processes are in green status. So with this, I can confirm that HANADB is up and running. Since it is yellow, I would have to rework on this and make it green. So that was about checking the status of HANADB once we do stop and start. Now let us proceed to learn more about stopping. So when it comes to stopping HANA database, as I said, stop start can be done using OS commands, that is using HTTP program and SAP control program. And again, stop start can be done using HTTP Studio, that is HANADB Studio. So for that, what you have to do is you have to log into HANA Studio, right click on the system and choose stop. But before you do that, you have to log in with user SID ADM credentials. or you can log in with DB admin user also, like system user, and then issue stop. So when stopping through HANA Studio, it will give us a pop-up to choose what type of stop do we have to choose. There are two types, hard and soft. By hard we mean a hard shutdown forces all database services on all hosts to stop immediately. If it is single host, one host; if it is multiple, then multiple. So hard mode will abruptly stop all the processes. It will force to stop all the processes. Whereas coming to next mode, that is stop, a soft shutdown triggers a save point operation before stopping. So it will trigger a save point. Though the save point is not scheduled to run at that time, if we choose soft mode, a soft save point operation will be run before the shutdown of the database. So we have a consistent save point data before the stop. So unlike hard mode, soft mode will ensure consistent data before the stop. And also we get to choose stop wait timeout. This value specifies how long to wait for a service to stop. If the timeout expires, the remaining services are shut down anyway. So stop wait timeout is the duration that the stop command will wait for until all the services are stopped. Say for example, I give 100 seconds. So for 100 seconds, it will wait without stopping. I mean, without abruptly stopping. That is, services should go down by itself once we issue the stop command. If that does not happen within 100 seconds, then HTTP stop or studio stop will proceed to stop abruptly all the services. And next, see, when administrator editor opens in diagnosis mode, the database services stops one by one. Okay, so when we issue stop, the administrator console or the editor moves to diagnosis mode. That is, we mean that all the services are getting stopped. So in the diagnosis mode, we can see all the diagnosis files only. And when all the services are stopped, we see a red dot which appears on the system icon in the systems view. And when the system is stopped, there is no SQL connection. SQL connection to the database is not operational when the system is stopped. Only through SAP Start SRV, the Studio can talk to HANA database to get the diagnosis files information. Hence, HANA Studio collects information about the database using the connection of the SAP Start service using diagnosis mode. That's what they say. So now let us see in HANA Studio how this. See, now I have logged into HANA Studio. I'm connected to a chain database, and now you see that here are the start, stop, restart options, but all these are disabled. Why? Because since with my previous stop start, the services were not started completely. See, this is where you can verify the status. Go to landscape. In the services tab, you see that few processes are not started properly. So I'll try to start them manually from here. We can also start the individual processes from the HANA Studio. See, once I started these services manually, any service here can be started manually if it is not started. We just have to navigate to landscape services tab and choose, right click and start missing service. You can also stop, kill, also check memory allocation statistics, reset memory statistics. We can also reconfigure if any changes with respect to this particular service is made in the ini file of the respective service, then we can reconfigure. Just reconfigure. It will, if it is dynamic in nature, if the value can be changed dynamically, then you can just reconfigure here. Now let us learn about stopping. Since everything is green here now, except for SAP Start SRV, that is due to the connectivity issue. This also should be ideally green. Now let me proceed to stop. This is how I stop. I choose the stop option and then I can proceed to stop. Once I click on that, as I said, I will be prompted for whether soft or hard, or also I can mention the timeout, that is stop wait timeout. So if I choose soft, I can mention the date and time. Date and time are mentioned here for scheduling. I can schedule the activity as well. And hard is immediate and it aborts immediately. So using soft option, I can probably schedule the time I want to restart this. Say now the time is 6:21. I can increase this to 6:31 and say stop at 6:31, and also mention the wait timeout value. Coming to hard, I cannot schedule this, but it stops immediately. So I choose cancel since I don't want to do it. And again, coming to starting, I can choose the start, and start timeout value will also be asked. So if I say stop, I say hard, then okay, then it proceeds to stop. See, as soon as I stop, I will be taken to diagnosis mode, and this is how the status of HANA turns into. And in this, I can see all the diagnosis files. While it takes some time to populate the files, we have to be patient. So that was about how to stop SAP HANA using the HANA Studio, and then how it moves to diagnosis mode and what can we check in diagnosis mode. So in diagnosis mode, we can check the diagnosis files for analysis. And why it moves to diagnosis mode is because there is no SQL connection to database possible when the database is stopped. HANA Studio can talk to database only through SAP Start SRV process. Now let's move on to understand how to start SAP HANA using SAP HANA Studio. So in a similar fashion, we have to log into the system with SIDADM credentials or DB admin credentials, and from there we have to right click and then choose start on the system in the systems view. And when starting, the administration editor which opens in diagnosis mode and the database services start one by one. And when all the services are started, we can see a green dot on the systems icon in the navigation view. And optionally, see, once we start, we get a pop-up like this to mention the start wait timeout. That is, it is the time that can be specified how long SAP Start SRV waits for a service to start. So if I give 400 seconds, so for each service start, it waits for 400 seconds and then it aborts. It says service cannot be started. So this is how long the wait program or the start program should run until the instance is started. Say 400 seconds, as I said, is issued for the entire system. Okay, it will wait for 400 seconds until all the services are started. Then it aborts saying it could not be started within the wait time. Then we have to analyze what was the issue. See, now the database is in stopped mode. Now let us start using the start option. See, this is the standard wait time. See, as I said, this is the wait time mode which defines how long the instance should run the start program. That is how long it has to wait for the instance to start completely. If the timeout is exceeded, the remaining services of the instance are not started. Okay, I choose yes. So right now the system is in diagnosis mode. It continues and then it starts the system. So I have to refresh. So now I can navigate to administration console, that is the administration editor. Just double click on it, or we can right click and choose administration, or from here I can just click on this button to take into admin console. Right now there is some problem with the server connectivity, that's why we see this error. We might have to analyze this error. Let us refresh. See, now the error is gone. Now it is still there. Okay, what it says is connection to database server lost. Check the server and network status. What happens at times, there is a preference option for selecting the network connection. Under general we can choose network connection. Sometimes with the mode that we use here, the connection to server may not work properly, so we normally change it to native at times and then apply. We try different options so that the connection to server works fine. Still we have the issue. Now we see that the status of HANADB has turned into green. That is, all the services, all the component services are now green except for SAP Start SRV, which is probably due to a connectivity issue to the database server. And under the overview tab, you can see that all the overview information. You can see started service time, which was first started today, and the latest started service time for today. And it still shows some services are not started. That is because of SAP Start SRV, which is not running. And also at the OS level, you can issue get process list and see that. Right now you see that STB daemon is green in color. That means all the processes are running fine. So with this, you have restarted the database by stopping and starting. But also there is another option where you can directly choose to restart. This will automatically stop and then start as well. See, first it will ask you for the stop mode, whether soft, hard, whether you want to schedule it, whether you want to stop it immediately, and also mention the stop wait time mode. So you can choose anything. Again, it goes to stop and then starts automatically. So you would have to wait for some time until it is started, and then you are good to proceed. See, now we see that HANADB is automatically started as well. So the restart option will stop the system and start automatically. Now that we have understood how to start SAP HANA database using SAP HANA Studio and also using the OS commands. Now let us know when the system is started, what activities runs in SAP HANA database. That is what happens internally. See, when SAP HANA database is started, there are certain activities which are executed. For example, the database receives the status of the last committed transaction. That is, the previous committed transaction is rolled to the new status. That is, the previous committed transaction is the point to which the start of SAP HANA takes SAP HANA database to. So we get the latest committed transaction log in picture here, and the system reaches that point. Next is all the changes of committed transactions that were not written to the data area are redone. So any committed transaction which is still left in memory and not written to data area are now redone. So anything committed staying in memory itself are now redone, and all write transactions that were open when the database was stopped are rolled back. So any transaction which was still in write operation which had not committed are rolled back. Since these are not committed, they are not in stable state, these transaction logs will not be considered, whereas only the committed transactions are considered. Though they are in memory, they are written to data area once the system is started. And row tables are loaded into memory. By architecture, we know that row tables, which are mainly system tables, are kept in memory. So all these row tables are loaded into memory. And for column tables, it is lazy loading. That is, only relevant column tables which are marked for loading and their attributes are loaded into memory asynchronously in background. This happens in background and asynchronously. It is not continuous. And a save point is performed with the restored consistent state of the database. A save point operation is performed with the restored consistent state of the database. We will get a new save point created in the database as soon as the system is started. And also, we can manually select which column tables and which columns are to be loaded into memory from the HANA Studio. Okay, so these are the activities which runs internally in SAP HANA database when the system gets started. And the status can be verified as we know from Landscape Services tab. So that was about verifying the status of the SAP HANA database in the Landscape Services tab. Now let's move on to understand how to start individual database services. If you remember, I had shown in SAP HANA Studio in Landscape Services tab how we can choose to start individual services. But internally, as a feature in SAP HANA, we know that there is an auto start watchdog function which will continuously monitor the status of all the services, that is all the components of SAP HANA database. And if any service has not been started or has stopped, this watchdog function will try to automatically start it. Okay, so but at some cases we see that even the watchdog function will not be able to start the services, especially start the services. So in that case, what happens, we have to manually start the individual database services. So for that, we need to log into HANA Studio, choose landscape and choose services subtab under landscape. And using that, we can start individual database services like name server, index server, statistics server, access engine, and so on, running on hosts. And even in case of multi-node system, we can start, stop individual services running on each host. And to start, stop, the user doing it must have the privilege service admin. And there are multiple options as it was shown. We can either stop, kill, reconfigure, start the missing service. Stop, where the service is stopped normally and then typically restarted. Kill, the service is stopped immediately, then typically restarted. There will be some wait time with stop, but kill is an abrupt stop. And reconfigure, as I said earlier, if we reconfigure the configuration of any particular component, then we can choose to reconfigure the service in the landscape services option. That means any dynamic values, any dynamic parameters which are changed, the values of the same are applied when we reconfigure the service here. And start missing service, any inactive services are started. Okay, this action can replace the auto start watchdog function. If auto start watchdog function was not able to start any stopped service by itself. And we know that the administration editor opens automatically in diagnosis mode. And what are those situations? The situations could be when the system in the HANA database studio is not able to talk to the database with an SQL connection. And when we initiate the start, stop, restart of a function, the system moves to diagnosis mode, then comes to online mode. So basically, before start or when we stop or when we restart, so restart has both stop and start. In the stop function, it moves to diagnosis mode, and during start, it moves from diagnosis to online mode. And there could be other situations like a host in a distributed system failed and a standby host took over. We know the idea of distributed system where multiple hosts or multiple instances are running for achieving high availability. In case any of the active instances has gone down, one of the standby instance will take over the action of the active instance. And second is after an update of SAP HANA access service, that is extended application service, the access engine service needs to be restarted. So these are like situations where we have to do manual restart of the services. And also we should remember that in case of multi-node systems, we have to log into that particular host to stop start the instance running on it, or using the studio we can do it directly. Now let us move on to understand how we configure SAP HANA database. Starting with configuring properties for SAP HANA systems, when we have added system in the systems view of HANA Studio, we will navigate to its properties, that is by right clicking on the system in the window and selecting properties. We will get these options where we can mention different settings. Firstly, the database user logon, that is we can save the password of the database user, that is the credential of the database user in the secure storage, so that every time we log in or every time we open the HANA Studio, we can start using the HANA system added there without having to logging in again and again. And in additional properties, I would show you in the HANA Studio directly. Where in additional properties we mention the connection details and what are the hosts used to connect for this system. And next is about JDBC trace, where we enable the JDBC trace to identify potential issues with the HANA Studio connectivity. We can enable the tracing here with this option. And next is license option, where we install the HANA license. So this tab shows us information about the installed HANA license, about its availability, that is the duration, and about the permitted memory for the HANA database, and information about the hardware key as well. And also we can install new license keys if the existing license has been expired. And next is about resource. We can change the description of the system here. And SAP system logon, where we can enter and store SID ADM credentials. And next is about security, where we can maintain SAML identity providers. SAML is security assertion markup language. Once we have enabled SAML in the system, we can maintain its identity providers in this security tab. And coming to version history, which shows version of the HANA database and their installation time. If we have installed a version and then updated, we can see both the versions in this version's history. And next is about access properties, where we can maintain access host. See, now I have logged into HANA Studio. I've navigated to the properties option by right clicking on the system and choosing properties. First option is database user logon. As I said, we can store the password of the database user with which I have logged in the secure storage, and also I can mention the password of current operating system user. And next is, yeah, the connection details, as I told you, the host IP and the SQL port that is being used. I can choose to auto reconnect if there is any disconnection due to any issues. And hosts which are used, you can see the host name and the corresponding IP address here. Coming to JDBC trace, we can enable the trace by checking this box, and we can limit the size of the trace so that the trace file does not grow very big and trace gets split into multiple traces. And coming to license, as I told you, we can see what type of license is installed, what is the duration. As I have already explained, temporary license is valid only for 3 months. We can see that this has 3 months duration. And what is the peak memory allocation? In GB we have given 24 GB. And what is the hardware key? And here is the option where we can delete the license key, install a new license key as well. Moving to resource, this would show the description what I have given here, which is editable. Okay, and coming to SAP system log gone, as I told you, here we can mention the password of SID ADM user and store it in secure storage. This is other option. This is for database user logon. You can choose what kind of authentication you want. Earlier choice was to choose database user. I need to apply this. But if I want to connect using the operating system user, then I have to choose this, and I have to go here where I can store the password in the secure storage. And coming to security SAML configuration, here I don't have any identity provider name since I have not configured any SAML configuration here. So once I set up SAML configuration, I can see some identity providers here. If I want to add some, I can directly choose this add and do. Also edit, delete. Version history, which would show the versions installed in the system. So since the first version what we installed is still present, it shows only one version. if I do an update and then I navigate here, I can see another version here. The latest version will be updated in the second row. Moving to access properties, this will show the access host along with its port, which is 80, and the instance number by default. And we can choose to use HTTPS if we have configured HTTPS, that is SSL, secure socket layer for HANA database. So this was all about the properties for SAP HANA system. See, here is the option. If I have to show you, right click on the system, choose properties to navigate there. So with this we have understood how to configure properties of the HANA system in the HANA Studio. Now let us move on to understand how to actually configure the parameters in SAP HANA database. The main operation of SAP HANA database on its operational state depends on the parameter values what we have set for different sections in the INI files. That is, for different configuration parameters, we can customize the values based on the need, based on our environment, and make the HANA database operate with these values. And how do we do this configuration? There are two possibilities. One, by using the HANA Studio, navigating to configuration tab, but make sure for doing this we are with a proper, that is with an appropriate database user, and this user should have the privilege in file admin, like how for stop start we had service admin system privilege. For configuration we need to have in file admin system privilege to do any changes or any customization for the configuration of SAP HANA database. And second option is at the operating system level. We can navigate to the local system properties location or global system properties location and make the changes accordingly in the INI files, and then take the restart if the restart is required. But SAP recommends to make the changes using the HANA Studio in the configuration tab and not at the operating system level. In case if the system is not accessible, has been crashed due to some unplanned events, and if we have to make some configuration changes to bring it up, then it makes sense to log into operating system and making the changes in the INI files respectively, and then starting the system. So here is the picture of different INI files in the configuration tab. Just have to navigate under each tab and make the changes accordingly. And we see that to distinguish parameters that are valid at the system level, there are settings at the system level and at the host level. This basically works in case of a multi-node system where there are multiple hosts, that is multiple instances running on multiple hosts. So to have a setting at an instance level or at the system level, we can navigate to configuration tab and make the changes accordingly. And after making the changes, we will see a green color icon, green color circle icon, either at the system column or at the host column, depending on the changes made. If it is made on the host level, then we see an icon there in the host column. If we have made at the system level, we can see the icon here. So green icon appears only if we have customized on top of the standard setting. And we can see a disabled icon in either system or host level. That means the validity at the system or the host level is disabled. If for example, if you take here, if I navigate to any parameter, you will be able to see. Let me do that. Here in HANA Studio, you can see that I have navigated to preprocessor.ini configuration file. Under the communication section, I have chosen the parameter default underscore read underscore timeout. If you see, default value is already chosen by standard installation. And if I want to set any new value, I can set it, but only at the system level. Here I would see another box where I can do the setting at the host level, which is not present here. That means the value setting at the host level is disabled. Accordingly, if you see here, you see this disabled icon for the host column. So this would show that this value setting or this parameter setting is not possible at the host level. It happens only at the system level, which is global in nature. We cannot have a local host level setting. Whereas if I navigate to any other parameter, say I would take backup parameter file, see if the parameter setting is possible at both system and hosts level, we can see both the boxes here, and we can choose to set the value at the system level or at the host level. Here I can drop down. If I have multiple hosts, I can choose which host I want. Here, since I have only one host is visible, then I can say OK, or I can select all also, but this would mean same as doing the setting at the system level. So if I want to do settings at the individual hosts, I can choose them, say OK, then set the value. I would get the selection box here, names of the hosts which are selected for this setting, then set the value and then save. Once I save it, I will get, see if I just choose something, save, then see. If I deviate from the standard setting, I can see this green color circular icon for the corresponding setting made, whether system or host. And if I say restore default and then save, the green color icon is gone. It is no more. So any such configuration changes, be it for backup or memory or access engine setting, we have access engine.ini file and statistic server.ini file. So any changes with respect to any component of the HANA database should be done using the HANA Studio configuration tab. And if a restart is necessary, yes, we have to restart. If this is dynamically configurable, then go to landscape services, choose, and then since daemon cannot be done independently, any other service, choose reconfigure service. Since daemon is a parent process, we cannot do the configuration on that because we wouldn't have done any specific configuration setting at the daemon level. It is not possible. So that was about making the configuration changes for SAP HANA database using the HANA Studio. And speaking about configuring the HANA database using the operating system files, as I told you, you have to navigate to system level, that is global configuration file location, or to local instance, that is under STB instance server name, which is the host name location, which has local configuration files, and make the changes accordingly. And speaking about a few standard or very important configuration files which have certain customer specific configuration settings and which are created during installation. They are SAP profile.ini, daemon.ini, nameserver.ini. These files are stored in the local instance location under the server name, and these are the information that it would contain. SAP profile.ini contains the system identification information. It has the local instance information which is used for the operation. So if we want to know the local instance information, we have to navigate to SAP profile.ini and see its information such as SID, instance number. So if we want to run any sort of scripts, any cron jobs, which would read the information about the local instance installed and do any activity based on that, we can do a scan of this SAP profile.ini and then do the activity required. Next is daemon.ini, which contains information about the database services to be started. So it has information about what database services must be started with the start program. And moving on to nameserver.ini. Nameserver.ini contains global information for each installation. The landscape section under that contains the system specific landscape ID and assignments of hosts, like whether it is master, worker, or standby. So in case of multi-node system, we will have multiple hosts present, and each host will have a role, whether it is a master or a worker or a standby. So such information can be found directly in the nameserver.ini, or the other option is always using the HANA Studio. So at the operating system level, if you want to know this, then this is the file which can tell us. And all other INI files are generated if customer specific changes are made to them after installation. So that means only these three files are generated with standard installation by default. And all other INI files, like for example indexserver.ini, global.ini, statisticsserver.ini, accessengine.ini, are created at the operating system level only when we make any customer specific settings, that is any sort of customization in the HANA Studio. They are then created at the operating system level. So from then onwards, we can navigate to operating system location and then make the changes accordingly. So as I told, we can know the disabled icon in the host column if it is not relevant for the host level setting. And for making any parameter changes, we have to, as I told you, either double click, make the changes, or right click, choose change under the particular configuration file under the section that we want to choose. Now you can see I have logged into the HANA database server, and after switching to SIDADM user, I am under the instance directory of HANA database. Under that I have the server name directory, host name directory. Here it is HANA OS. So once I log in inside the directory, I can see daemon.ini and SAP profile.ini along with other directories which are relevant. So if I open the contents of SAP profile.ini, I can see the system information. I can see the instance number, system name, that is the SID, instance name, that is HTTP01, and local host. And similarly, daemon.ini, where it shows the services to be started: statistics server, access engine, SAP web desk. Now similarly, if I have to check the system level configuration, that is global configuration files, I have to navigate under global directory, under sys, and navigate to subdirectories HTTP custom config. There I can see nameserver.ini, which has come by default with the standard installation, and the contents of the same is like this. It shows the landscape ID, which is unique for each system, and we can see the master server, worker, and which is the active master. If I had multiple hosts here, I would have seen different host names with different roles assigned. Like I would have had HANA OS for master and HANA OS 1 for worker. If I had a standby like HANA standby, then I would have had standby is equal to HANA standby. And here you can see global.ini also. This is not created by default at the operating system level, but since I made changes to global allocation limit, that is in between I made a change to the memory manager section, that is by changing the value of global allocation limit. So after that, this file has got created at the operating system level. So this has information about the memory allocation and persistence paths like data volumes, log volumes, and system usage type, that is test system. So that was all about configuring SAP HANA. Now let's move on to understand how to do SAP HANA table administration. See, we know that in order to load data into any sort of RDBMS databases, we need to create tables. So similarly in HANA database too, we need to create tables to load data and also decide on its storage type. And to decide on its storage type, we have to know the use cases where it is used. In SAP HANA, by storage type, I mean whether row based or column based storage for the particular table. And to create a table, we must have the right authorization to create objects under the schema where we are working. So right authorizations must be given to create objects under any schema that we are working. And coming to creation of table, there are two ways. One is by using the SQL commands in the SQL console. We have to make use of such a format of SQL where we mention the create table type, table name, and table content source, table creation option list with other parameters where we can mention some parameter key value list. So based on the use case of this table, various parameter key values can be set for creation of the table. And coming to table type, I mean whether it is column or row, history column, global temporary, local temporary. And next option is using HANA Studio. So in HANA Studio, we have to, from systems view, open the catalog schema as shown here. Under catalog, choose the schema that we want. And in the context menu of the schema in which you want to create the table, choose new table. Enter the table name here and table type, whether column store or row store. Then define the columns of the table that we want, the name and its properties. And if required, we can add indexes too. And then we can choose the create table option. Similarly, we can create new indexes, new synonym, and new view under tables. Okay, so here is where we can see whether it is column store or row store and the schema that we have chosen. And also if we want to check any table whether it is row store or column store, we can again navigate to catalog and the respective schema, open definition, and then we will get this picture again where we can see the table name, schema, what type, and the columns present, and with few more information like what are the indexes for the properties and the runtime information. So coming to table definition, this view provides information about the table's structure, so about the table's design and its properties, and detailed information relating to table's memory usage and size ID are available on the runtime information tab. So basically the runtime information tab would show information about memory, data consumption, and compression of individual columns. And coming to table content, this shows a select on the table. Basically, executes a select statement on the table. It shows the actual records present in the table. If I want to see the content of a particular table, what it holds, then I can just choose open content and it would show the records present in the table. It is so easy. And coming to data preview, data preview is advanced option to table content, but it shows a graphical picture of the contents present in the table, which would help us in making an analysis in case of any decision making or in case of any performance analysis. We can just choose to open the data preview and understand with the graphical picture that we have there. See, for example, if I want to check the definition, contents, and data preview of a table under schema SAP HANA admin. And what I have to do in the systems view under catalog folder, navigate to the schema and choose tables and then right click on the table that I want to see, open definition. Okay, here is the structure of the table. You can see the table name, schema under which it is present, what type of storage it is in. So, and these are the columns and the data types. And any indexes that it has, nothing. For the properties, whether have you mentioned any temporary table type, any comments, and the runtime information where it would show the memory consumption, the disk consumption, and memory consumption by main, delta storages, and the compression. You can navigate and see its creation time. So basically, complete information about the same and its column size too, and the compression ratio, what I told, by what level it is compressed. And also similarly, I can open the content to understand what records it has, and I have insufficient privileges to do this. So basically, I don't own this schema completely, so I'm not able to do a select. And coming to data preview, again insufficient privileges. Let me open something with system. You can see now I have opened under sys schema, chosen the table afill underscore functions. You can see it does a select. Opening content would do a select. So by default it opens first 1000 entries, but this is customizable. We can select to open more entries. There's a configuration setting which must be done under the preferences, and these are the entries present. And if I want to do an analysis on this, I would open the data preview, and yeah, see this, see data preview information. It shows the contents, shows distinct values where I can drag drop and create a graph. This would create a graph for me for making any analysis, and I can see the statistics of the same year. And also the analysis tab would show more information again. See, this is the graph. I can choose to add some more IDs. See, such kinds of graphs based on our analysis we can generate and then use them. See, analysis tab would show different types of charts that we want for comparisons. I can choose different types of graphs again to understand. So for any reporting activities, we can use this. So that was all about table administration, where we learned about creation of tables and how to read the contents, open its structure, and do a data preview, that is to analyze the table contents. Now let's, yeah, this is the same picture as what we learned. Now let's move on to understand the table partitioning and distribution. Why do we do table partition? Table partition is basically performed for very large tables present in the HANA database. And these large tables are broken down into smaller chunks. As a result, they become easily manageable. So if we see any large tables and if we see that there is a need to break them into smaller chunks so that it can be easily consumed, easily operated on, then it makes sense to perform table partitioning. Table partitioning can be done on a single host system and as well as multi-host systems, that is multi-node systems. But preferably it is mostly done in multi-host systems to leverage a better performance out of the multi-host scenario that we have. So partitioning is typically used in distributed systems. So coming to the definition, the partitioning feature of SAP HANA database makes it possible to split column store tables horizontally into disjunctive subtables or partitions, which can be operated on different hosts in case of distributed system, and make use of the parallelism option and use of the multi-core scenario that we have with SAP HANA. And what are the advantages? Well, before coming to advantages, let me explain you about how we can do these partitions. There are certain DDL statements which are used for creating partitions. So technically we make use of DDL statements which are available to create such partitions. And also using the HANA Studio, we can navigate to a particular table, right click on it and choose partition and then do the partition. So with this, basically using the DTL statements, we can create table partitions, repartition tables which are already partitioned, merge partitions to become one table, delete partitions which are not necessary, move partitions to different hosts. In case we add another host and we would have done a partition prior to adding host, we can move the partitions which are relevant to be moved for new host for load balancing. And partitioning can lead to several advantages. What are those? They are, firstly, load balancing. In case of load balancing, individual partitions can be distributed across multiple hosts. This means that a query on a table is not processed by a single server, but by all the servers that host partitions. So, by having a table split across three hosts, I can operate on the table on all the three hosts instead of operating it on a single host. So by that way I can achieve load balancing. So in this case we will not put the load on a single server, but we will distribute the load across three servers to leverage its resources. Next is overcoming size limitation of column store tables. How? A non-partition table cannot store more than 2 billion rows. It's a standard setting. But now it is possible to overcome this limit by distributing the rows across several partitions. So, so that, but here the limitation is that each partition must not contain more than 2 billion rows. But we can still overcome the limit of 2 billion rows for a particular table by making partitions. Okay, so that's how we can overcome the size limitation of column store tables. Next is coming to parallelization. Partitioning allows operations to be parallelized by using several execution threads for each table. Exactly. As I gave the first example where a table can be split into three parts and can be operated parallelly using separate threads, we can operate on a single table, and that's how we can achieve parallelization and also use the multi-core CPUs efficiently. Next is partitioning pruning. We know that queries are analyzed to determine whether or not they match the given partitioning specification of a table. If a match is found, it is possible to determine the actual partitions that hold the data being queried. So basically what happens, using this method, the overload or the overall load what is present on the system can be reduced, thus improving the response time. We will not overload the system. Using this method, we can avoid overloading the system. So overall load on the system comes down and thus improves the response time. And next is about improved performance of delta merge operation. We know by delta merge, we are trying to avoid a big impact on the input output on the disk. So the performance of the delta merge operation depends on the size of the main index, right, of the main memory. If the data is only being modified on some partitions, fewer partitions will need to be delta merged, right, and therefore performance will be better. So having partitions, we are taking load on only certain partitions, not all the partitions. So delta merge is not always impacted by high input output, whereas only certain partitions inside the delta merge are taking the load. So on an overall basis, the performance will be better. Next is about explicit partitioning handling. In this, see, we know that applications may actively control partitions. Speaking about an example, by adding partitions to store the data for an upcoming year or a month. So we can have this explicit partitioning handling. We can create partitions on the go. And there are several ways of achieving the partition by basically specifying how the rows are assigned to different partitions. Now that we have understood the advantages of having partitioning feature, now let's move on to understand what are the different supported levels of partitioning techniques. These are termed as single level partitioning techniques. So firstly, hash partitioning. Hash partitioning is used to distribute rows to partitions equally for load balancing and so as to overcome the 2 billion row limitation for column based tables. So this is used to equally divide the load, where we distribute rows to partitions equally, and the number of the assigned partition is computed by applying a hash function to the value of a specified column. So we make use of a hash function here to determine what kind of or what level of partitioning we want. Next is about range partitioning. Range partitioning can be used to create dedicated partitions for certain values or certain value ranges in a table. So based on the value range or the values, we create partitions here. Now coming to round robin partitioning. Round robin partitioning again is used to achieve an equal distribution of rows to partitions, similar to hash partitioning. But unlike hash partitioning, we do not have to specify partitioning columns here. Okay, that's the difference. With round robin partitioning, new rows are assigned to partitions on a rotation basis. In general, we know the round robin technique, it uses the rotation basis. So here also, rows are assigned to partitions on a rotation basis. And the table here must not have primary keys. This is a condition for round robin partitioning. So these are the partitioning techniques that can be implemented. These are the single level partitioning techniques to be specific. And with the latest HANA revisions, a new feature called time selection partitioning is possible. So this technique allows application data to be horizontally partitioned into different temperatures like hot and cold, which is more effective in nature. So that was about what is table partitioning. Now, how do we partition this is something we should know. So as I told, we have to right click on the table under the particular schema, or right click on the schema itself and choose the table distribution editor. This is the table distribution editor. So basically, to analyze performance issues, this table distribution editor can be used to understand how tables are distributed across multiple hosts present in the distributed system. And it is also possible to know if a table is distributed to several partitions and on which host each of these partitions is stored. And existing partitions can be moved to different hosts also. So the movement of partitions can also be done. So what are the options in this editor? We can move tables, partitions to other hosts, partition non-partition tables, change partition table into non-partition table. We can reconvert a partition table into non-partition table. But before moving tables or partitions, the system checks that the host has sufficient memory or not. In case we plan to move a big partition to a new host added. So before moving, SAP HANA will internally perform a check to check if there is enough space in the new host or not. If not, it will display a warning so that we can increase the memory and then do the partitioning. See, now I have logged into HANA Studio. I have selected SAP HANA admin schema. Right clicking on it shows the table distribution editor. Yeah. So here there is no partition created. So we don't see anything updated here. So here I can choose to configure table. These are the possible options available, and if the partitioning is done, we can see details of the partitions. Yeah. And likewise we can choose to do the partition by selecting the table, click on partition table and use the function that we want. So whether range or hash, specify the numbers. We can also have additional level of partitioning again, that is repartitioning. So there are basically two levels, first level and then second level possible here. So here again we can choose what type we want and specify the settings accordingly. And now once the partitions are created, there are certain checks which can be done on the partitions. First is general check and then data check, and if there are any problems present with rows, we can do a repair rows. So general check is basically done to check only the partitions, whereas data check checks the partitions plus also checks if all rows are located in correct paths or not. So based on the result of these checks, we will do a repair. Repair will repair rows located in any incorrect paths. If any incorrect paths are there for rows, that will be corrected using the repair rows functionality. And the SQLs for the same are given here. We can use call check table consistency where check partitioning function is used, and for data check, check partitioning data is used on the schema and the table that the partition is present for. So with this, now we have understood how table partitioning is done and how consistency check on the table partitioning is done. Now let's move on to understand how we can manually load unload tables to memory and from memory, and what is delta merge and how do we do this delta merge. See, we all know that main feature of SAP HANA is to keep all data in memory and operate on it for quick response. Basically, a big cache is kept in HANA database for faster input output. And SAP HANA itself manages automatic load and unload based on the data access. That is, loading tables, unloading is automatically managed by SAP HANA itself. In case if there is an out of memory issue, SAP HANA itself will unload irrelevant tables, that is unwanted tables which are less used to disk and thus saves memory. But on the other hand, SAP HANA allows us to manually choose a table or table columns and do the load into memory or unload from memory if they are not wanted. So technically, load unload options are available just to free up memory. And load specifically is to make a table be present in memory for faster access. Unload directly points to freeing up memory. How these load unload are done? Basically, again, there are two options using SQL commands and HANA Studio. So from HANA Studio, you can see you can choose the table and choose option load into memory or unload into memory accordingly. Other option is using SQL commands. We can choose load, provide the table name, unload table name, and also if columns are to be selected for a particular table, provide load table name and the column name and more columns of our choice. Similarly for unload, unload table name and the column names accordingly. So these are the two options available for us to manually load, unload the tables. And next is about delta merge. What is this delta merge process? See, memory management in HANA controls the data merge process automatically. This delta merge is basically used to reduce the input output on the disk. Every time if we have to do the right operation on the disk, it would be very expensive. So to avoid this, SAP HANA has this inbuilt feature called delta merge, where a delta storage is kept in memory and any write operation or read operation is done from this delta merge. And based on certain conditions, certain thresholds, the data in this storage, that is delta storage, is written into disk for persisting the data. And it is useful to trigger a merge operation manually in some situations. Basically, for example, we can think of an alert which has been issued because a table is exceeding the threshold for the maximum size of the delta storage and we need to free up the memory. And how do we do this delta merge? Again, we have two options to do delta merge. That is, choose the table, right click on it, use the perform delta merge from the HANA Studio, and the other option is use the SQL command merge delta of the table name. We have to provide the table name here. And likewise, we can choose multiple tables at once for merger. So then the chosen operation is executed for all the selected tables. Should know that load, unload, merge are available in the context menu of a specific column store table always. Now let us understand about some of the periodic operational tasks a HANA admin has to perform on a day-to-day basis. So these tasks would define the main roles of a HANA admin in administering and monitoring the HANA database. Firstly, apart from monitoring the database on a day-to-day basis, but before monitoring, implementation comes into picture. So once the HANA is implemented for a particular environment, for a particular scenario, monitoring it on a day-to-day basis is the first task. So first task and the main task which runs throughout the life cycle of the implementation. And then other major tasks would be like firstly performing a full data backup, a file system backup at regular intervals for safeguarding the system and troubleshooting any issues with respect to that if the backups are not happening. And that would be termed as an initial task because we need to have one full backup as soon as the implementation is completed before the customer starts using the system. And once the customer starts using the system, regular backups should be running at regular intervals. And now coming to regular tasks, checking the system status and status of individual services, system is checking that the system is perfectly operational. And for that, one has to regularly monitor the alerts, monitor the logs for any errors or warnings and correct them immediately so that we don't see any major disaster. Monitoring along with analyzing the performance, read the traces generated by default or by default trace is active so we can make use of it. If not, we can enable other types of traces for particular analysis and do the analysis on the performance and then improve the system behavior based on the actions that we can take. And check the volume growth, that is disk volume growth, data growth, and resize the system accordingly, that is scale up the system accordingly or scale out the system if necessary, add multiple hosts, create a distributed system for load balancing, for achieving parallelization, and assign different roles. With multi-node we can also create HADR situations, achieve that, and do the configuration settings. So regularly if you want to change some configurations, maintain the configurations, do a restart, stop start operations, and some of the on-demand tasks like checking the diagnosis files and activate and analyze additional traces. As I said, avoid logful situations which are very important. If logful situation appears, then the database freezes, that is database moves to non-operational state and we have a downtime, an unplanned downtime here. So avoid such logful situations. So make sure we use the appropriate log mode and also trigger regular log backups and avoid log backup area becoming full. Make sure the log backups taken at the file system level are moved to tapes on the backup server so that backup part does not become full. So basically disk monitoring again. And monitor disk space again used by the diagnosis files. We know that we generate a lot of diagnosis files. If we enable tracing, then there is huge load on the disk. So basically, when the tracing is enabled, make sure you utilize the traces and then disable the traces. And speaking about other operational tasks like making schema mapping or setting up SLT replications, monitoring the SLT replication, and other activities like deploying contents, export, import of contents across systems, performing partitioning. Well, this list keeps growing. There are a lot of tasks as an admin to be performed. Well, that was a general idea about what are the operational tasks an admin has to perform. Now let's move on to understand transport of changes. So by transport of changes, we mean any contents, that is packages or delivery units developed or deployed, are transported across systems, and how this can be achieved will be learned here. See, we know that SAP HANA repository has both design time and runtime objects. By design time, we mean contents, and runtime, we mean catalog. And these design time objects on activation become runtime objects. So, this is how repository holds contents and catalogs. And coming to SAP HANA Application Lifecycle Management, which is also termed as HALM, HALM. In SAP HANA, see that several objects can be developed to build standalone apps and are transportable. So these are the objects which could be design time and runtime. A picture of all these objects is shown here. This is a picture from the HANA Studio where you can create these sort of objects. And the picture here shows what are runtime and what are design time. As I told you, all catalog objects are termed as runtime and all contents are termed as design time. So upon activation, these design time objects are transforming into runtime objects. So basically, these design time objects are termed as HANA content. So what are HANA contents? Also termed as objects or artifacts, are termed as design time objects delivered as a part of SAP HANA optimized solution or created. And these objects are assigned to packages, and then packages are assigned to delivery units. So this is how it goes. Contents get assigned to packages, packages are then assigned to delivery units, and these delivery units are transported across the landscapes. And for ensuring consistency when transporting objects, it is important to ship objects that belong together at the same time. So all objects that belong together for a particular functionality should be shipped together always. And now coming to packages. All content delivered as a part of the application we develop for SAP HANA are stored in packages in the SAP HANA repository, and they are arranged in hierarchy that are defined to help make the process of maintaining the packages transparent and logical. So this hierarchical storage can help maintaining the packages transparent and logical. And coming to delivery units, as I told, a delivery unit is a collection of packages that are to be transported together, right? And we should assign all the delivery packages belonging to the application to the same delivery unit to ensure that they are transported consistently together within the system landscape. And to create managed delivery units, we must first maintain the identity of the vendor. Since each delivery unit has a unique identity which consists of two parts, a vendor name and a delivery unit name. So to define this name, firstly we need to define a vendor name, which is a parameter value in SAP HANA. So this vendor would define with whom the delivery units are associated and in whose namespace the packages that make up the delivery unit are stored. So basically a typical basic transport landscape we know that would contain development, a test and a production system. So these delivery units are moved across from dev to QAP and then to production accordingly. That's how the transport of delivery units would take place. But make sure we define the parameter content underscore vendor with the right value so that the delivery units are creatable and then transportable. And this HALM, SAP HANA Application Lifecycle Management, enables to create the product, the delivery unit, package, and basic application components that we want. And additionally, SAP HALM enables administrators to set up the transport of these delivery units that we have created, monitor the transports, and also upload or download delivery unit archives accordingly based on the scenario that we are going to use. And by transport, we mean we can export catalog objects to file system and then import them back into another database. For example, if we want to move data from a test system to a productive system, clone the system or provide the data to SAP support so they can replicate a scenario. That's how it works. So basically, import export can be chosen from the catalog directly in the HANA Studio. So with this, we can export or import either metadata or metadata and component. So either metadata only or combining metadata with content can be exported or imported. So basically, any column store table or a procedure or a sequence can be exported in either there are two formats, binary or CSV format. But a row store table can be exported only in CSV format. That's the difference here. A column based table can have both binary and CSV formats, but a row store has only CSV format. And then once we export, the exported data by default goes onto the database server. But it is also possible for us to export to a local client machine also. And with importing, this imported data will create the tables in the same schema as it was in the source system. And if the table already exists, we must mark a flag there for it to be overwritten. Otherwise, if we don't mark it, what happens? We will face an error message saying import failed. The import will automatically abort. See now, for example, if I want to export the contents of this, I choose right click and then export on the schema. I choose the object that I want to export, choose next. So this is the screen where I can do the selections, whether binary or CSV. Since this is a column store, I have both the options, whether only metadata or including the data and the dependencies. And I choose the export location. This is the default file system layout on the database server where I can export, or I can choose a client directory. I can choose any of the local drives for storing. And I can select the number of threads for performing this export. And likewise, I can choose to import the content. I have to store the content file in the respective location which I am choosing and then choose accordingly and do the import. So that was about exporting, importing contents with respect to SAP HANA system. Now let us understand about transporting native SAP HANA content using HALM. You know that Help enables administrators to set up the transport of delivery unit, start, monitor, upload, download delivery unit archives, which we studied in the previous slide. And to understand more about where we have this Helm is available with the SAP HANA Access web server. This is the link to access Helm, where we have to use the HTTP or HTTPS if HTTPS is enabled. Use the HANA database server name, provide the port of the HANA Access. It is 80 on the instance number, and use this extension to log into Helm directly. And this Helm covers two aspects. One is platform lifecycle management for customizing, where we run all sorts of customizing. And second is updating SAP HANA platform, where we run updates, and also application lifecycle management for managing SAP HANA content, products, and transports. So basically, two sections are like it has platform lifecycle management for customizing and updating the SAP HANA platform, and another is application lifecycle management for managing SAP HANA content, products, and transports. So to summarize, it has platform lifecycle management and application lifecycle management, where platform lifecycle management is used for customizing and updating the HANA platform, where we do any sorts of customizations and updates. And coming to application lifecycle management, it manages the HANA content and manages transports of the same. So here basically objects would be schemas, tables, privileges, or roles, analytical views, attribute views, procedures, calculation views. All these objects are regarded as transportable content. Yeah. And this SAP HANA HAL, as we know, is available through web server. So we need to configure Access engine appropriately so that Access web server is available and can be operated to use HAL. And we should have the right admin role, that is administration role, to enable access to all options and tools in SAP HAL. And then after that, we can define the route and then export the transport. And additionally, there are certain options in HAL which are very important, like change tracking and dependency viewer. Change tracking is responsible for recording of changes and transport too. That is, it offers options for managing content in a promote to production system landscape, and it offers automatic recording of changes to a change list, similar to how we have transport management in an ABAP system. And basically, as a developer who would work on a development, would develop artifacts, and then it is possible to release the change only when the artifact is ready to promote to the test system for testing purpose. It basically provides more precise control over which objects get transported from the development system. So for change tracking and for gaining more control, we have this change tracking functionality in HAL. And next is dependency viewer, which is basically a graphical tool to display the dependencies. Basically, it would show dependencies between delivery units. So graphical depiction is interactive in nature here, and it can be rotated. There are various options available and shifted around to provide different perspectives. So technically speaking, dependency viewer would help us in knowing which delivery units should be transported together. So which delivery units are dependent and should be transported together can be understood using the dependency viewer. And next is about enhanced change and transport system, also termed as CTS plus. This CTS plus is an integration of SAP HANA into CTS, which we can export, import the HANA contents. So using CTS plus, we can perform export import of HANA contents and manage them. So basically the CTS option of ABAP what we had has been enhanced for HANA database also. Here we can see the CTS plus, and this has certain dependencies like to use CTS plus with HANA. Some prerequisites apply, basically like Solman manager with the CTS plugin must be installed, and SAP HANA database must be configured into Solman to operate on this. Then we are good to operate different HANA systems. Basically would consider like dev, QAP, test, and then manage them from CTS plus tool. This figure where it shows the transfer of data model from one system to another. So technically how it works is for export to run, HANA Studio connects to HANA database source system. The data model data will be exported to the file system first, and the data model will be uploaded via CTS transport organizer web UI CTS and attached to a transport request. A transport request gets created here, and the transport requested will be released via the transport organizer. And once it is released for import, as soon as the import is started in TMS, the deploy web service client hands over the data model to the deploy web service available. And the deploy web service starts the transfer of the data model to the target system involved. And then to finalize the import, we have to start the HANA Studio and connect to the SAP HANA database target system. Then we trigger the import for the data model to retrieve the import results. So that's how a content can be exported and imported with the help of CTS. So with this, we have understood how the transport of changes can be done. So this concludes the end of this topic.